Hotep family, Di Ankh Mira. Welcome to mathematics lesson number 3. If you like what you see, please share and subscribe. The primary objective of these units is to be able to do calculations using sacred script of our African ancestors, Medu Neter. We are all students and teachers. This lesson will use Nile Valley numerals or Middle Neck numerals, as you may, to make connections between the Hindu Arabic numerals that we use currently in this country. Arithmetic is one way of doing mathematics or one way of developing our learning skills. In Middle Netia, our ancient ancestors called that process of learning Gem Mek Nefer. Our African ancestors created these symbols to represent the base 10 or decimal system. The base 10 or decimal system is the same numerical system used today in our classrooms and throughout most of the world. For this lesson, we'll be using the Lunetian numerical symbols, along with these familiar Hindu-Arabic numerical symbols. The Hindu-Arabic numerical symbols are as listed below. These are the symbols that we use, or the digits that we use, to create all of our numbers. In lesson 2, we looked at doubles using the Medunetya doubles, Medunetya numerals. So here they are one more time. Starting from the left to right, we have 1. Double 1, you get 2. Double 2, you get 4. Double 4, you get 8. Double 8, we get 16. Double 16, we get 32. And double 32, we get 64. So if we write the Hindu-Arabic numerals below the Medunetya numerals, we see the pattern 1, double 1, we get 2, double 2, we get 4, 4, we get 8, double 8, 16, from 16 to 32, and 32 to 64. And if you remember, in the Hindu-Arabic system, it's a place value system. So for a number like 64, we have 6 tens and 4 ones, with the 6 is in the tens place and the 4 is in the ones place. In the Medunetya symbols, we have 6 groups of 10 and 4 groups of 1, and both represent 64. Here are the doubles of 3 in Hindu-Arabic, shown with the factors in the Lunetya. So we have 1 3 is 3, 2 3s is 6, 4 3s is 12, 8 3s is 24, 16 3s is 48, 32 3s is 96, and 64 3s is 192. We can see a similar pattern with the doubles of 5. So we have 1 5, 2 5s, 4 groups of 5, 8 groups of 5, 16 groups of 5, 32 groups of 5, and 64 groups of 5. There is also an interesting relationship between the numbers or the digits in front of the 0 in each of these multiples of 5. Can you see what I'm referring to? The Wajet, or the Eye of Heru, appeared in lesson number 1. We want to make note of the fact that the denominators of these unit fractions, as they're called, are doubles of 1. In this case, we want to look at the doubles of 1/64, or 1 over 64. So 1 over 64 is 1 over 64. Two groups of 1 over 64 is 1 over 32. Four groups of 1 over 64 is 1 over 16. Eight groups of 1 over 64 is 1 over 8. 16 groups of 1 over 64 is 1/4. 32 groups of 1 over 64 is 1/2. And 64 groups of 1 over 64 is 1 over 1, or 1 whole. So another way to look at this is if I start off with 1 or 1 over 1, which is 1, and take subsequent halves. So first half of 1 is half of a half is 1/4, half of 1/4 is 1/8, half of 1/8 is 1/16, half of 1/16 is 1/32, and half of 1/32 is 1/64. There's some interesting relationships here, and these are called unit fractions. So our African ancestors used the set of symbols indicated below in indicating these unit fractions. Well, the 1 is a whole number of 1 over 1. Then we have the 1/2, which is represented as part of a ship. 1/4 would be the mouth with 3 vertical lines below, the center line being longer than the outer two. 1/8 is the mouth with 8 vertical strokes below. The 1/16 is a mouth with 10 and 6 vertical strokes below. The 1/32 is a mouth with 3 tens and 2 vertical strokes below. And 1/64 is the mouth with 6 tens and 4 vertical strokes. These are the same unit fractions that we see in the Eye of Heru, the magical eye that was created by Netjer Jehuti when Heru lost his eye in a battle with his uncle. So here's an example of how we would use halves to find the fractional parts of 12. So we have the whole number 12, which is the whole 12, 12 divided by 1. And then we have 6, which is 12 divided by 2. We have 3, which is 12 divided by 4. We have 1 and 1/2, which is 12 divided by 8. We have 1/2 plus 1/4, which is 12 divided by 16. And then we have 1/4 plus 1/8, which is 12 divided by 32. And 1/8 plus 1/16, which is 12 divided by 64. Going from left to right, we start with 12, then half of 12 to get 6, half of 6 to get 3. Half of 3 gives us 1 and 1/2. Now, half of 1 and 1/2, we would usually write that a little differently, but when it demonstrates something. So what we get here is the half of 1, which is a half, and then half of a half, which is 1/4. And likewise, moving along, if we take half of a half, we get 1/4. And half of 1/4, we get 1/8. And finally, if we take half of 1/4, we get 1/8. And half of 1/8, and we get 1/16. So let's take a minute to see how that works with the Medu Neter numerals. So starting with 12, which is 10 and 2, or a 10 and 2 ones, which is an even number, kind of easy to work with, because half of that 10 would give us 5, and half of the 2 would give us 1, and 5 plus 1 would give us a 6. So half of 12 is 6. Well, 6 is also an even number. We have 3 ones over 3 ones. If we want half of that, that would be easy. That just gives us the 3. Taking half of 3, well, we could take half of 2, which would give us 1. And then half of the 1 that we didn't use would give us a half. So we get 1 and 1/2. We take half of the 1, and that gives us a half. Half of the half would give us 1/4. So we get 1/2 plus 1/4. In Medu Neter, we do not have those plus symbols in the fraction bar. But moving right along, if I take 1/2 of the 1/2, that's again 1/4. And 1/2 of the 1/4 is 1/8. So we get 1/4 and 1/8. If we take half of the 1/4, we get 1/8. Half of the 1/8, we get 1/16. So we have 1/8 plus 1/16. Again, we do not have the plus sign, the fraction bar, and all those other things in the uses of Medu Neter. So we can use halving to have, as I call it, or as they call it, any number. So let's start with the number 25 and see how that works. So we know 25 is 2 tens and 5 ones. So we are going to start off by finding half of the 2 10s and half of the 5 1s. So we have each part of the Meadow Netcher symbols, and so half of 2 10s is 110. The 5 1s is an odd number, so we will take half of 4, which is 2, and then we'll take half of the remaining 1, which gives us a half. So we can see that half of 25 is 12 and a half. So as we continue, we want to take half of 25, which is a quarter of 25. And again, we can take half of the 10, which gives us 5 1s, and half of the 2, which gives us 1 1. So that gives us a total of 6 1s. And half of a half is 1/4. So far we have the whole 25, we have half of 25, which is 12 and a half, and we have a quarter of 25, which is 6 1/4. So this is kind of straightforward because we take half of 6, which gives us 3, and half of 1/4 or half of a quarter, that gives us 1/8. So if we look at the progressive halves of 25, we start off with 25, then half of 25 is 12 and a half of 12 and a half is 6 1/4, half of 6 1/4 is 3 1/8, and half of 3 1/8 is 1 plus 1/2 plus 1/16. So we can look at the same pattern using both the Meadow Netjer symbols and the Hindu Arabic symbols. What I have written in terms of the Hindu Arabic is the 12 plus 1/2, but we normally just say 12 and a half, and we do not put the plus sign there, which is always confusing to students because even though we say things like 12 and a half, um, students don't recognize that there is a plus sign there. And the terminology that we are given for these sets of numbers vary depending on the teacher, the textbook, and the time that you are introduced to them. But for the most part, we identified some of these as mixed numerals, some as improper fractions. And the 25 by itself is a whole number. I also indicated that it is often written in algebra as A over B, or the quotient of A and B, where A is the numerator, B is the denominator. So the first number, 25, can be written as 25 over 1. The second number can be written as 25 over 2. The third is 25 over 4, and 25 over 8, and then 25 over 16. So that turns out to be the exact same idea as halving the number progressively from taking half to 1/4 to 1/8 to 1/16. So one strategy that we learned in schools at some point is if I have a fraction where the numerator, the a value, is larger than the denominator, the b value, we say that that is an improper fraction, and we are taught to rewrite that as a mixed numeral, where we would get a whole number and a fraction, a proper fraction. So I want to show that 25/16, which I rewrite as 1 plus 1/2 plus 1/16, is the same as 1 and 9/16. The rule for finding, one of the rules for finding or adding two fractions with unlike denominators is to find the common denominator or the least common denominator. So if I'm adding 1/2 plus 1/16, I discover that the least common denominator is 1/16. So I can rewrite 1 over 2 or 1/2 as 8 over 16. And now I have 8/16 plus 1/16. And the rule that we learn is you keep the same denominator, which is 16, and you add the numerators, which gives you 9. So that shows that 1 plus 1 half plus 1/16 is the same as 1 and 9/16. Another very interesting pattern using the Meadow Netja is when I have the number 100. So 100, I start with the, again, Meadow Netja symbol for 100. If I take half of that, that's 5 tens. If I take half of the 5 tens, well, again, 5 tens is an odd number, so I could take half of the 4 tens, which give me 2 tens, and then half of the 1 that's left over, which give me 5, so I get 25. Half of 25, again, half of the 2 tens is 1 10. If I, again, 5 is an odd number, so if I take the 4 numbers, take half of that, it gives me 2, and half of the 1 that's left over, that gives me a half. And then if I take half of the 12 and a half, well, 12 is an even number, so that's going to give me a 5 plus 1, which is 6, and half of the half is 1/4, so I get 6 and 1/4. So the pattern is 150, 25, 12 and a half, 6 and 1/4. These numbers are called rational numbers. In fact, even the previous numbers that I identified, they're identified as rational numbers because they can all be written as numbers with a denominator. Or I could write this as 100 over 1. I could write this as 100 over 2. I could write it as 100 over 4, 100 over 8, and 100 over 16. So I want to show how this can be applied to percentages, because 100 could be identified as 100%, 50 as 50%, the 25 as 25%, the 12 as 12.5%, and the 6 and 1/4 is 6.5%. That's one way of getting to percents using these halves. We also use a representation that we call decimal fractions. Sometimes it's just called decimal, which can be very confusing because all of our numbers are decimal numbers. It's just that some of them are decimal fractions. So for instance, the number 1 is a decimal number. It's a base 10 number, whereas 0.5 or 0 and 5 tenths is a decimal fraction. 0 and 25 hundredths is a decimal fraction. 0 and 125 thousandths is a decimal fraction. And 0 and 625 10,000ths is also a decimal fraction. And they are equivalent to those percentages that are listed above because the percent sign is simply identifying a division by 100. So there's one way that we can apply this arithmetic logic to identify relationships between percentages of other numbers. Here's how it looks with money. So if I want to find percentages of $350, I could start by saying that the $350 represents 100%. 50% is half of that, which is $175. 25% is one half of the 50%, which is $87.50. 12.5% of $350 is $43.75, which again is a half of one half of one half, or half of 1/4. And finally, if we wanted to get 6.25%, we could just take half of the 12.5%, and that would give us $21 and $21 and rounded off, we would say 87 cents or 88 cents, depending on whether you're receiving the money or giving the money. But that's a story for another lesson. So we can actually look at this using the Meadow Netja symbols for 1, 1/2, 1/4, 1/8, and 1/16. And we could actually apply the same process because we have 350 divided by 1, 350 divided in half or by 2, 350 divided by 4, 350 divided by 8, and 350 divided by 16 to get each of those corresponding percentages. So I can also represent this as the whole number being divided by one of the doubles, or in this case, 350 being divided by 1, which is 100%, 350 divided by 2, which is 50%, 350 divided by 4, which is 25%, 350 divided by 8, which is 12.5%, and 350 divided by 16, which is a 6 and 1/4%. We can make some other connections between the Middle Nechi numerals and the Hindu-Arabic numerals. Take, for example, the halves of 64. So we have a whole 64, half of 64, 1/4 of 64, 1/8 of 64, and 1/16 of 64. Or 64 divided by 1, 64 divided by 2, 64 divided by 4, 64 divided by 8, and 64 divided by 16. So if I look at what happens with the number like 65, which is an odd number, and it's one more than 64, instead of getting just 32, I will get 32 and 1/2. And when I find half of 32 and 1/2, I'll get 16 and 1/4. And half of 16 and 1/4 is 8 and 1/8. And half of 8 and 1/8 would be 4 and 1/16. So we can rewrite 65, which is an odd number, as 64 plus 1, giving us an even number and an odd number. So we have 64 plus 1 divided by 1, 64 plus 1 divided by 2, 64 plus 1 divided by 4, 64 plus 1 divided by 8, 64 plus 1 divided by 16, and hopefully we can see how those relate to the halves of 64 and the halves of 65. And in fact, if we take this a step further into the realm that we call algebra, this is a application of what's identified as the distributive property of division over addition, which says that if I have two numbers being added and divided by the same number, I can divide each number by that denominator or divisor, which is also the reason we can add two fractions with common denominators. And it is also possible that we can write these numbers using the Hindu-Arabic system and using what's identified as the decimal notation. So the 65 becomes 65 and no hundreds, and 32 and a half becomes 32 and 50 hundredths, and 16 and 1/4 becomes 16 and 25 hundredths, and 8 and 1/8 becomes 8 and 125 thousandths, and the 4 and 1/16 becomes 4 and 625 10,000ths. So just to sum up this lesson, I want to say that everything starts with the number 1, the concept of oneness. We do doubles starting with 1, and we take 1 and then we double it and double that and then double that. And for halving, we start with 1 and then we take half of that and half of half and half of a fourth and so on. And we could use those concepts to find any product or any quotient of any two numbers. In my next lesson, I want to focus on finding the quotient of numbers and how we could do that using, again, the Middle Nechi symbols, and also connect that with the Hindu-Arabic numbers that we use. So this brings us to the end of lesson, or I should say arithmetic lesson number 3. I have produced and I'm creating some worksheets that go along with the understanding or basic understanding of the Middle Nechi numeral system. If you are interested in getting free copies of these worksheets, which are on PDFs, I will gladly share them with you. You could indicate your interest in the comments. Shem Hotep.